So we're going to pick up right where we left off in the last one, except on these. So the last video, we talked about the 68, 95, 99.7 rule. And in that example that we did, the score that we were looking at, 700, fell right at 2 standard deviations above the mean. And that's the only time you can use that rule. So in this case, as you'll see, where do you stand if your math score was 680? So 680, you can calculate the z-score. That would be a z-score of 1.8, which is not 1, 2, or 3, obviously. So we have to do something different on this. And so you need your calculator on this, your graphing calculator. And these are actually easier. It's actually kind of easier to do it this way. And it's more precise. So let's see how we're going to do this. So the first thing, again, like on the last one, first thing you should always do is draw a picture. And so you'll draw your normal curve, and then we put the mean in the middle. Now in this case, because if you did add and subtract the standard deviation, you'd see the 680 is not going to land on there. So let's just put the 680 on here somewhere. Just put it on the correct side of 580, put it over here. And we're again going to look for the percentile. So what percentile are you in if you score 680? So we're looking for what percent of the scores are below 680. So we're looking for all of that area. Now, one of the things that the picture will help with, or at least it's a good idea to draw it. You maybe get to the point where you don't have to draw the picture, but I would certainly recommend you draw the picture in the beginning while you're learning this. And one of the things that will help you with is now looking at the picture, assuming you drew it correctly, you know the answer is not going to be 25%, and it's not going to be 30%, it's not going to be 10%. So we have shaded majority of this picture. So your answer, your percent, what percentile are you in, should be 85, 90, 95%, something like that. So let's see how to do this. Now on your graphing calculator, you're going to go to second bars, and I may post. I'll see if I can find a video, YouTube to upload that kind of shows you on the actual calculator how to do this. But the bars button, maybe I can. Let's see. The bars button is going to be right there, so right under the arrows, and so you're get that. Bring up the menu, and you want to pick number 2, which is normal CDF. Now, some of you, depending on if you have the 84 or the 83, will see different things here once you select number 2. So if you see that, you can see you see lower upper mean standard deviation. That just tells you what to put in. If you don't see that, it's okay. So you may just see normal CDF with a parentheses. So if that's the case, you're still going to do these same numbers in the same order. You're just going to have to type in out like that. All right, so lower, it's talking about the lower bound of your shaded area. So the lower bound would be the left bound. So what's the lowest score you could get? That would be 0. Upper bound would be the right side of the shaded area. What's the highest score we're looking at? 680. And then the mean, which is 500, and the standard deviation, which is 100. So if you don't have that menu on your calculator, like I had on mine, you're going to type in these 4 numbers in that order, and you're going to separate them by commas. And the comma is right above the 7. So you're 0, comma, 680, comma, etc. And then you hit enter, and we should get 0.964. All right. So I would also suggest do these along with me in these videos, just so that you can, if you get stuck, you can email me right then, and we'll figure out what the issue is. Although it's possible we'll have to do a Zoom call to figure that out if it's anything too complex, but that's how you do it. So second bars, number 2, normal CDF. So the C stands for cumulative. So we're accumulating the data as we come along. So that's what the C is for. Then we have number 5, what proportion of SAT scores fall between 450 and 600? So let's again draw a picture. And we'll put the mean in the middle. Now we're going to put 450 and 600. Doesn't matter too much how far out you go. I mean, I kind of made it symmetric. Obviously, 450 is closer, but picture is just a guideline. You don't have to be perfect. And then we want between, so we're going to shade between. All right, we're going to go to the same menu that we did on the last one, second bars, number 2. And what is your lower bound going to be? It's the left side of the shaded area, which is 450. Then the upper bound, right side of the shaded area, 600. The mean, still 500. And the standard deviation, still 100. Put that in the calculator, and we should get 0.5328. Now, this one, it may be a little bit trickier to get a good estimate of what the percent could be. So aside from that, the picture is also useful for seeing the lower bound and upper bound pretty easily. So it can help with the estimate of the answer, but it can also help with just kind of a guideline to what you put in the calculator. All right, so number 6, suppose a college admits only people with SAT scores in the top 10%. How high a score does it take to be eligible? All right, so one thing, this one's different because on 4 and 5 and number 3 also, we were asked to find a percent. So the 0.5328, the 0.964, and number 4, those were percents. This time we are given a percent, and we were asked to find a score or a data point. So this one is the opposite of what we were doing. So let's draw a picture, and the picture is going to be slightly different in what we label. So we're still going to put the mean in the middle. But this time we are looking for some score up here so that 10% is above it. Okay. So now we cannot use normal CDF for this because that calculates a percent. It does not calculate a score or a data point. So we're going to go to second bars, but now we're going to pick number 3, which is inverse norm. And when you do inverse norm, and if you had a menu on these up here, you will have a menu on this. And if you didn't up here, you're not going to here, but same idea. You're going to put the same 3 number, well, this time 3 numbers. You're going to put the same numbers in the same order. So if you do see the menu, you'll see area. This is area to, let me rewrite that. No, it's terrible. This is area, maybe not. All right, area. This is area to the left. To the left of X. So what area is to the left of X? 10% is to the right. That means 90% is to the left. So we're going to put 0.9. And then we just have our mean and our standard deviation. So if you don't have the menu, just type 0.9, comma, 500, comma, 100. And then we should get 628. And again, picture can help. So obviously, if I'd ask you what would you guess, you would not guess 450. You would not guess 400. You would not guess 425. Your guess would be above 500. So if you get an answer below 500, that automatically tells you that you did something wrong. And the most common mistake on these, where you're supposed to use inverse norm, is to put the 0.1. If you put the 0.1, then you get a number over here, because the 0.1 would be the area to the left, and that would be somewhere over here. So be very careful when you're doing these. if it asks for the lower 10% or the lower 20% or the bottom 10%, bottom 20%, and you're somewhere over here, then you would put 10% or 20%. But if you're talking about the top and you're shading that way, you have to put the area to the left. So you got to flip the percent. So just be aware of that, be very cautious, and kind of try to estimate what or at least guess, like, is it above 500 or below 500? Or below the mean, above the mean. So what would you guess it'd be? And that'd be a good guideline. All right, a couple more, and let's look at number 7. So based on experience, a manufacturer makes cereal boxes that fit the normal model with a mean of 16.3, standard deviation of 0.2, but the label reads 16 ounces. What fraction will be underweight? Let's do the picture. And the mean is 16.3, and we want, and again, notice 16, 1 standard deviation below would be 16.1. 2 standard deviations below would be 15.9. So that is 1.5 standard deviations below. So you cannot use the 68, 95, 99.7 rule. And in fact, you really only will use that if it explicitly says to use it. So on the homework, it will say, according to that rule, what proportion is above or below or between, whatever. If it doesn't say that, we're going to use the calculator, use the normal CDF or the inverse norm, as the case may be. So what fraction will be underweight? We're going to go, actually, let's go overweight just to show something here. So let's change that to overweight. So are we going to use the normal CDF or the inverse norm? Well, we're looking for a fraction. It says fraction, but percent is the same as fraction. So we're looking for a percent. So that means we're going to use we're going to use normal CDF. So normal CDF, what is the lower bound? So the lower bound, the left side of the shaded area is 16. What is the right side of the shaded area? Well, technically there is no right side. Like there is no end to this. This curve actually goes on forever. It just gets closer and closer to 0, but it never actually touches 0. So there is no end technically. But obviously when it gets closer and closer, you're not really contributing much more to the area. So whenever you don't have an upper limit like this, just over some number, but it never really ends, just put some big number. And I usually just hit 1 and then hit a bunch of zeros. Then we put the mean, and then we put the standard deviation. And you can play with that number a little bit. And like if you put 17, that's probably not enough. It might be enough, but it's probably not. If you put 16.5, that's obviously not going to be enough. If you put 1,000, or you put 10,000 or 100,000, you actually will get the same answer. So when you have these where you need to go up to some big number, the bigger the better. At some point, it doesn't matter. So just make sure you go high enough, in other words. All right, so we put that in, and we should get 0.0668 for that. All right. Now we could say, let's add a little part to this. Where would the bottom 20% be? So the bottom 20%, we'll put 16.3, and let's find some x so that 20% is below. So we're just kind of making up an extra part here. So in this case, we would use inverse norm. So x is inverse norm, and before we do it, would the answer be more than 16.3 or less than? It'd have to be less than. So let's go to inverse norm. I don't have this one. I just made this one up, so we got to put it in the calculator. Area to the left is 20%. So when we're on this side, we do not change that. We go with what the percent that we're looking for, because the area to the left. Then 16.3, and then 0.2. And let's see what we get. 16.3, 0.2, and we get 16.13. All right. So yeah, so make sure you're comfortable with those. When do you use normal CDF? When do you use inverse norm? So we'll kind of divide this. So those are two separate ones. All right. In the serial example, what is the IQR? So if you remember, IQR is Q3 minus Q1. So we need to find Q3, we need to find Q1. So let's find Q1. Actually, before we do that, let's draw a picture. Put the mean in the middle, 16.3, and then we're looking for Q3 will be somewhere over there, Q1 will be somewhere over there. Now, what do we know? How about what percent is between Q1 and Q3? That would be 50%. So going back to chapter 2, so this is kind of bringing stuff from chapter 2. So the 50% between Q1 and Q3, how much does that leave in the tails? That leaves 25% and 25%. All right, so how do we find Q1? We're given a percent, we need to find a data point. That means we're going to use inverse norm. What's the area to the left of Q1? That would be 25%. So 0.25. And our mean and standard deviation, put that in the calculator, and we should get 16.165. And then Q3, inverse norm. What's the area to the left of Q3? 50 plus 25, that's going to be 0.75. And then 16.3, and then 0.2. We put that in the calculator, and we get 16.435. And then we can do IQR, subtract those. 16.435 minus 16.165, and we should get 0.270 for the IQR. Okay, so went through that one a little bit fast. Maybe go back and rewatch it if you have to. It's not super difficult, but you need to understand what the IQR is. It's not just, when I do this in class and ask how can we figure this out, they'll say, well, add subtract standard deviation and it's between that. Well, no, that's not right, because if you add and subtract one standard deviation, now you're 68% between those two. We need the two such that we have 50% between. And if you wanted to do, we could do even where is the central 40%, in which case you would put 40%. You would do Q1 and Q3, just do like X1, X2, 40%. Now, how much would you have on the tails? And then you kind of do the same thing. So if you have any questions on these, again, these are very important for what we're going to be doing the rest of the course. So it's very important to understand how to do these, and you're very comfortable doing them. If you get good at these, especially these last few that we're doing on the calculator, it's really, really hard to be tricked. Like I could ask almost anything regarding these, and if you're good at them, they're all the same. I mean, there's nothing complicated about this once you get pretty good at this. So for sure, if you have any questions, email me and we'll set up a time to figure all this stuff out for you.